Every year, across the United States and many other countries, billions of tons of agricultural products make their way from the fields to our tables. In the past, harvesting relied entirely on manual labor. But today, modern farming machinery has turned entire fields into massive automated production lines. Thanks to these machines, labor costs have dropped sharply, harvesting speed has increased many times over, and post-harvest losses are now at some of the lowest levels in history. Farms spanning hundreds or even thousands of hectares now require only a handful of operators to run the equipment. In today's video, we'll step into the world of giant agricultural machines, tree shakers, automatic fruit harvesters, high-speed root crop diggers, pesticide-spraying drones, and specialized harvesting systems found in only a few countries. Stay until the end to see how they work, and why many farmers say that modern agriculture wouldn't be possible without them. The citrus harvesters in Florida operate like open-air factories, where every movement is calculated to maximize efficiency. On farms that span hundreds of hectares, mechanized harvesting systems serve as the backbone of the entire season. Each machine is built around two main components: a clamping frame that grips the trunk, and a hydraulic shaking system capable of adjusting its amplitude based on the tree's age, rigidity, and fruit size. Once activated, the clamp tightens around the trunk and delivers powerful, rapid vibrations, short but strong enough to shake ripe fruit loose in cascading waves onto the large catching trays positioned beneath the canopy. Each shaking cycle lasts only a few seconds, yet the yield can reach dozens of kilograms at a time with a level of consistency and accuracy that manual labor simply cannot match. These catching trays, often compared to metal hammocks, stretch along both sides of the tree rows and connect to a mobile conveyor system at the rear. Everything is engineered to minimize fruit-to-fruit impact. As soon as the oranges drop, the conveyor transports them into shock-absorbing storage bins. This design keeps bruising rates low even with mechanized harvesting, meeting the standards required for juice production, candied orange peel, and essential oil extraction. The efficiency of these machines makes them the true workforce of modern citrus farming. A single unit can process anywhere from 600 to 1,000 trees per day, depending on planting density and fruit maturity. Under ideal conditions, a small team of operators can complete the workload of 100 seasonal laborers. This is especially critical in Florida, where agricultural labor shortages occur frequently, particularly during peak harvest months. Still, machines don't replace humans entirely. Premium citrus varieties, such as Honeybell, Caracara, and thin-skinned specialty tangerines destined for the fresh market, are all picked by hand. Even a small surface scratch can cut the fruit's value in half, so growers rely on skilled pickers who use specialized clippers to snip each stem individually. Workers are trained to move quickly but delicately, often sorting fruit as they go while standing at the top of ladders. This is a stage where trunk-shaking technology simply cannot compete, because the priority in this market segment is not volume, but flawless appearance. Across Florida's vast citrus groves, the blend of mechanized technology and human craftsmanship forms a balanced harvest system. Machines handle the heavy, high-speed work. People take on the varieties that require finesse. This partnership is what allows Florida's citrus industry to maintain enormous production volumes while preserving the premium value of specialty fruit that demand near-perfect care. The sprawling vineyards of California enter their golden hour just as the sun slips behind the hills. This is when the sugar levels in the grapes stabilize, no longer fluctuating with the daytime heat, allowing the fruit to maintain its natural balance. For that reason, many large vineyards choose to harvest through the night, creating a rhythm of work that looks entirely different from the daytime scene. Under powerful floodlights, grape harvesters move with near-perfect precision, weaving between the rows like enormous sewing machines. These harvesters are equipped with hundreds of small, flexible shaker rods arranged along the sides of the machine. They mimic the gentle yet decisive motions of skilled pickers. Each rod can adjust its speed, amplitude, and frequency to match the ripeness and variety of the grapes. As the machine advances, the rods engage the trellis with a calibrated pattern of movement, separating grape clusters without tearing the skins or damaging the vines. The process is fast, smooth, and remarkably clean, creating a soft, constant patter of grapes falling onto the catch trays below, like rain tapping against metal. The catch trays are deep and wide, lined with shock-absorbing material to protect the fruit. Once the grapes fall in, conveyor belts immediately carry them into 3 4-ton bins positioned at the back of the machine. When a bin fills up, a specialized tractor swaps it out and transports it to a nearby collection point, where the grapes undergo rapid cooling to preserve their crisp freshness. The movement is continuous and perfectly synchronized, ensuring the harvester rarely needs to stop between cycles. The power of mechanization becomes unmistakable here. A single machine can match the output of an entire picking crew within the same period, clearing hectares of vineyard in just a few hours. This speed is crucial in the U.S. grape industry, where harvest windows arrive quickly and must be completed in a short time to avoid weather risks or shifts in fruit maturity. As a result, labor costs drop significantly, productivity climbs, and American grapes remain competitively priced despite large demand both domestically and abroad. In the cool night air, the harvesters glide steadily down the rows, their lights sweeping across the trellises like frames of a living documentary. Technology and agriculture merge seamlessly, ensuring that every cluster of grapes reaches consumers with its full flavor intact, the result of the quiet, efficient labor that takes place during the most productive hours of the night. Across the sprawling sweet potato fields of North Carolina, often called the sweet potato capital of the United States, the harvest process has been optimized to the point where manual labor is almost entirely eliminated. Modern sweet potato diggers are engineered around one critical principle: preserving the delicate, thin skin that determines both market value and storage life. The digging system uses large, thin, curved metal blades that slide gently beneath the soil, lifting the entire row at a carefully calculated angle. This adjustment distributes force evenly, minimizing cuts or abrasions on the potato's surface. As the blades raise the soil, the rear conveyor immediately receives the potatoes as they emerge. A constant, gentle vibration helps loosen the soil without causing rough impacts. Loose dirt, dry leaves, and fine roots fall away through natural openings along the conveyor. From the cab, the operator can monitor the entire process, adjusting machine speed and vibration levels based on soil moisture, an essential factor that directly affects cleanliness and the integrity of each potato. On large farms, sweet potato diggers often work in formation, running side by side to cover vast acreage in a short amount of time. Each machine can process 15 to 20 tons of sweet potatoes per hour, an amount that would take a manual crew several days to match. This speed allows farmers to take full advantage of the narrow weather windows, which is vital since sweet potatoes reach peak maturity for only a brief period before their skins begin to weaken or the soil becomes too wet after rain. Once the potatoes are lifted and lightly cleaned, the conveyor transfers them into large bins positioned directly behind the machine. From there, specialized trucks transport the bins straight to the farm's post-harvest facility. The potatoes then pass through an automated sorting system that evaluates size, shape, and surface condition before moving on to the curing stage, a process where the potatoes are held in a warm, slightly humid environment for several days. This allows minor surface scratches to heal naturally, extending storage life by weeks. Everything flows continuously, smoothly, and rhythmically, like an industrial assembly line laid across open farmland. The machinery handles the heavy tasks, digging, cleaning, transporting, while workers focus on monitoring quality and fine-tuning the system. As a result, North Carolina sweet potatoes are known not only for their natural sweetness, but also for their remarkable uniformity and clean appearance straight from the field, a testament to the seamless blend of traditional farming and modern technology. Few harvest processes are as unique or iconic as the way North Americans harvest cranberries. When the season begins, the bogs, kept dry for most of the year, are flooded until the water rises high enough to cover the entire bed. The water not only cushions the berries from impact, but also allows growers to take advantage of a natural trait. Each cranberry contains a tiny air pocket, giving it the ability to float when lightly agitated. This characteristic creates the signature scene of every harvest season, millions of bright red berries bobbing on the water's surface like a giant floating carpet. Once the water reaches the right level, farmers deploy specialized agitation machines, often called egg beaters, which move slowly across the bog. Their large rotating paddles generate a gentle but consistent current, strong enough to loosen the berries from the vines without damaging their skins. After just a few passes, the surface of the bog turns vivid red as the cranberries rise en masse. It's a moment many farms capture each year, an image so iconic that it regularly appears in advertisements, packaging, and even agricultural documentaries about North America. With the berries floating freely, the corralling stage begins. Growers use a system of floating booms, long, flexible barriers, to surround a small section of the bog. The booms are pulled gradually to tighten the circle, gathering the berries into one corner without creating strong waves. Precision is crucial here, as cranberries bruise easily if compressed too harshly or knocked together in turbulent water. As the booms close in, millions of berries accumulate into a dense, bright red pool, packed almost like a single cohesive mass. From here, high-capacity vacuum pumps take over. A wide suction hose is lowered into the corralled berries, using vacuum pressure to pull them into waiting trucks or bins positioned at the edge of the bog. The system removes excess water as it works, ensuring the berries don't become overly saturated before entering the washing and sorting lines. Thanks to this technology, hourly harvest volumes can reach tens of tons, far beyond what manual labor could ever achieve, especially with a water-based crop like cranberries. From the moment the bog is flooded to the final suction of berries into the truck, the entire process unfolds like a vibrant agricultural performance. The red water shimmering in the sunlight, the slow movement of machines, the floating booms closing in ring by ring. Everything comes together to form a scene so distinctive that one glance is enough to know it's cranberry harvest season. And through the combination of the fruit's unique natural buoyancy and modern harvesting technology, North America's cranberry industry has created a hallmark unlike any other crop in the world. Across the vast grasslands of Texas, Kansas, and Oklahoma, hay harvesting unfolds like a massive outdoor production line. When the grass reaches ideal height and color, farmers bring high-speed mowers into the field. Their blades spin thousands of times per minute, cutting cleanly at the base and leaving long, even windrows across the ground. Timing is crucial. Cut too early, and yields drop. Cut too late, and the protein content declines sharply. The mower can run for hours with a single operator in the cab, rarely needing to step out except to inspect the blades. After cutting, the grass is left to dry directly under the sun for 2 to 3 days. The drying time depends on soil moisture, windrow thickness, and weather conditions. During this stage, a tedder, equipped with light rotating tines, is often used to fluff and spread the grass, helping it dry faster and more evenly. Proper drying is essential. If the hay is still moist when baled, internal heat can build up, leading to mold or even slow smoldering combustion. Farmers typically test a few strands by hand. If the stems feel crisp and snap easily, the hay is ready for the next step. Once the hay reaches the ideal dryness, automated balers come into play. Moving along the windrows, the baler's pickup teeth gather the material into its compression chamber. Inside, a rotating mechanism packs the hay into either round or square bales, depending on the equipment design. Round bales usually weigh between 200 and over 500 kilograms, while large, square bales from high-capacity operations can reach nearly a metric ton. When each bale hits the preset size, the machine automatically wraps it with twine or netting to keep it tightly bound, then gently drops it onto the ground without breaking the form. The entire harvesting sequence, cutting, drying, tedding, and baling, can be handled almost entirely by one operator running the machines in succession. With mechanization, hundreds of hectares can be processed quickly, ensuring a stable feed supply for livestock throughout the winter. Stacks of finished bales arranged neatly across the field resemble giant outdoor feed warehouses, a clear testament to the efficiency of modern agricultural technology, turning open rangeland into an outdoor feed factory that runs smoothly, quickly, and with remarkable cost savings for farmers. Modern potato harvesters are often described as mobile industrial assembly lines, with every movement synchronized for maximum efficiency. As the machine enters the field, the sharp front digging blade is adjusted to a precise depth so it can slip beneath the soil layer where the potatoes rest. In a single pass, the blade lifts the entire row on a gentle upward slope, greatly reducing the risk of cutting into the tubers or scraping their skins. Once the soil is raised, the potatoes, mixed in with clods of earth, move on to a powerful but controlled vibrating conveyor. This conveyor is built with parallel bars spaced just wide enough for soil, sand, and small stones to fall through while the potatoes remain on top. The vibration intensity is adjusted according to soil moisture: lighter shaking for dry soil, stronger vibration for wetter ground to reduce clinging dirt. This system ensures that by the time the potatoes leave the conveyor, they are already cleaned to a basic level, ready for the next stage of sorting. Behind the primary conveyor lies a series of cleaning tables and lift belts. Undersized or damaged potatoes are removed, while tubers that meet size standards are carried directly into the holding tank. One of the standout features of this technology is the synchronized truck loading system. A truck drives alongside the harvester, and when the onboard tank reaches capacity, a cross conveyor swings out and transfers a steady stream of potatoes straight into the truck bed, all without the harvester stopping. This continuous flow allows the machine to run for hours with almost no downtime. In major potato-producing regions such as Idaho, Washington, and Michigan, a single harvester can handle tens of tons of potatoes per hour. On industrial-scale farms, an entire fleet working simultaneously can gather hundreds of tons in a single day, something that would be virtually impossible with manual labor. Rapid harvesting preserves freshness and reduces the risk of spoilage caused by moisture, cold nights, or early morning dew. This level of mechanization is one of the key reasons the United States ranks among the world's largest potato producers, supplying a massive processing industry that includes French fries, frozen potato products, and potato starch. Each potato harvester, with its dozens of continuously moving components, stands as a testament to the scale and sophistication of American agricultural modernization. Olive harvesters in the United States, especially in California, where the climate closely resembles the Mediterranean, are engineered to operate at maximum speed while still preserving fruit quality. The machine's two large arms extend outward like hydraulic clamps, enveloping the tree canopy from both sides. As the clamps close, the trunk and main branches are stabilized, allowing the shaking force to distribute evenly without breaking limbs. Inside the machine's shell, a high-frequency oscillation system delivers rapid, rhythmic vibrations. Within seconds, ripe olives fall like rain, dropping straight into the catch basin below with minimal impact. The catch basin is built as a sealed funnel system, ensuring that olives don't spill out as they often do during hand-picking. From there, the fruit moves onto a conveyor and is transferred directly into the large storage bin at the back of the machine. Because this process is continuous, no stopping to collect fruit manually, each harvester can handle thousands of trees per day. In orchards planted in straight rows, the machine travels down each line like a mobile factory, requiring only a single operator in the cab. Speed is a critical factor in olive oil production. Any delay allows enzymes within the fruit to oxidize, degrading the oil's quality and its distinctive flavor. For this reason, once harvest begins, farms must ensure the olives are pressed within 24 hours. High-speed harvesters make this possible, delivering large volumes of fruit to the mill quickly and preserving the freshness needed to produce true extra virgin olive oil. In large-scale growing regions, multiple machines often run simultaneously, moving one after another along the perfectly aligned rows. The sound of the vibrating units, the steady rush of olives pouring into the basins, and the bins filling rapidly create a distinctly industrial rhythm. This technology not only boosts production, but also ensures that every batch of olive oil retains the pure, delicate flavor demanded by premium markets. In the Netherlands, the vibrant tulip fields that attract visitors each spring are actually part of a bulb-growing cycle. When the flowers reach their peak bloom, flower-cutting machines are sent into the fields to remove every single blossom, allowing the plant to redirect its energy back into the bulb. Within minutes, entire hectares of flowers disappear, leaving behind neat rows of green plants focused solely on developing the valuable bulbs beneath the soil. When the leaves begin to yellow, a sign that the bulbs have reached their ideal size, the digging machines take over. Their curved blades slip beneath the soil, lifting large sections of root and bulb clusters in one smooth motion. Immediately afterward, a vibrating sieve separates soil and loose roots before feeding the bulbs onto a conveyor. Multiple filtering stages remove debris without scratching the delicate outer skin. At the end of the line, the bulbs are gently washed to meet cleanliness standards, then sorted by size and quality. Those that pass inspection are sent directly to climate-controlled storage, where temperature and humidity are carefully regulated. Thanks to this fast, precise, and fully mechanized harvesting process, the Netherlands is able to supply enormous quantities of tulip bulbs to markets around the world, ensuring that spring blooms brightly, even in places half a world away. Coffee harvesters are designed to mimic the motion of hand-picking, but on a far larger scale. As the machine operates, its two clamping arms close tightly around the tree, stabilizing the entire coffee plant. Inside, a vibration system runs at a moderate frequency, adjusted according to the ripeness of the cherries. The vibration is strong enough to detach the ripe red cherries, yet gentle enough to avoid breaking branches or shaking off excessive amounts of green fruit, an essential factor for maintaining bean quality. As the cherries fall, they drop directly into catch trays that extend beneath the canopy. These trays are built as sealed funnels, preventing losses and keeping the fruit from hitting the ground and bruising. From the trays, conveyors move the cherries into the storage bin at the rear of the machine. Thanks to this continuous collection process, the harvester can run for hours without interruption, pausing only when the bin is full and needs to be emptied into a truck or large sacks for initial processing. On large-scale coffee farms, especially those planted in straight rows, each machine can replace the labor of dozens of workers. It moves steadily through the rows, harvesting tons of cherries in a single day while maintaining a high ratio of ripe fruit. Rapid harvesting helps farmers avoid weather-related risks such as rain, which can trigger unwanted fermentation or cause cherries to drop prematurely. This light vibration harvesting technology not only reduces labor requirements but also creates a more uniform batch of coffee, making the drying and processing stages more consistent. The combination of mechanized equipment and modern cultivation techniques has produced an efficient, clean, and reliable harvesting system, one that large coffee-growing regions in Latin America, Brazil, and parts of the United States are now adopting widely. From the tree-shaking machines used in citrus orchards to the high-speed olive harvesting robots, modern agriculture is entering an era in which every harvest is no longer just the work of soil and weather, but the result of data, engineering, and human ingenuity. Technology is opening new doors for the agricultural world. Higher yields, lower losses, more consistent quality, and an increasing ability to adapt to climate change. Yet as machines grow smarter, faster, and more precise, a quiet question remains. Where will people stand in this future landscape? The answer is likely not about machines replacing humans, but about humans using machines to push the boundaries of what we can achieve. Behind every piece of equipment lies a designer's hand, a programmer's logic, and the intuition and experience of people who have spent their lives understanding the land, the plants, and the seasons. The future of agriculture is not the disappearance of human labor, but a shift in roles, from heavy physical work to tasks of oversight, control, and creativity. People will continue to make the decisions, while machines become the powerful tools that turn those decisions into reality more quickly and effectively. Looking ahead, automated agriculture doesn't just help feed the world. It fuels a greater dream, creating a sustainable farming system that works in harmony with nature, where technology doesn't replace but supports, doesn't overpower but partners. And perhaps, within that harmony, we will find the most meaningful answer to the future of global agriculture.